right, January 25th through the 29th, we are looking at lesson number 23, solution sets to simultaneous equations. All right, let's just go ahead and look at this. We're going to, our whole thing is we're going to be able to create systems of equations that have the same solution set as the given system. We're also going to be able to understand that adding a multiple of one equation to another creates a whole new system of two linear equations. Alright, so let's look at our opening exercise very quickly. Here's a system of two linear equations. Verify that the solution to this system is 3, 4. This should be very quick. All you have to do is you're going to substitute 3 in for x and 4 in for y. So 4 is equal to 3 plus 1. That works. Alright, so 4 is equal to negative 2 times 3 plus 10. So 4 is equal to negative 6 plus 10. That works also. So I should be able to, I've been able to prove that this is the solution to that system. Alright, so let's look at our exploratory challenge. Excuse me. Write down another system of two linear equations whose solution is 3, 4. This time, make sure both linear equations have a positive slope. Alright, so you can do several different things. Obviously, if we were in class, we would be able to discuss what we could do here, but I'm going to go ahead and show you. So I want to make sure I have a positive slope. Alright, so I'm going to use an equation. We'll let this be B1 and B2. And we're going to use y is equal to x plus 1. We can use that. And then I want to change my second equation. But remember, 3 and 4 also have to continue to work for this. So here's what I'm going to do. 2 times x minus 3 plus 4. Alright? So y is equal to 2 times x minus 3 plus 4. Alright, so it says verify that the solution to the system of two linear equations is 3 and 4. Alright, so once again, I'm going to plug in 3 and 4. So 4 is equal to 3 plus 1. That works. Alright, and then 4 is equal to 2 times 3 minus 3 plus 4. So that would be 4 is equal to 0 times 2 is 0 plus 4. So 4 is equal to 4. Now it says graph equations B1 and B2. Alright, so we're going to graph them. I'm going to create my graph here. Alright, so this is an intersection at 1. My slope is 1, 1. So up 1 over 1, up 1 over 1. It's going to continue to look like this. Alright, so I'm going to draw that. Line there. And then I've got y is equal to 2 times x minus 3 plus 4. So that would be y is equal to 2x minus 6 plus 4. So y is equal to 2x minus 2. So my equation is a negative 2. It intersects at negative 2. And it has a slope of 2, which means I go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And here's my line. And I see that they intersect right here. Are either B1 or B2 equivalent to the original A1 or A2, and explain your reasoning? We'll come back to that in just a second. I do see that 3, 4 is a solution because that's where they come together. All right. So it says are B1 or B2 equivalent to the original A1 or A2? So yes, I used the same equation for B1. as A1. Okay, so that's okay. B2 was different. All right. Let's go on and look at E. Add A1 and A2 to create a new equation, C1. So it says add A1 and A2. So we're going to add those together. All right. So y is equal to x plus 1. I'm going to add y is equal to negative 2x plus 10. I'm going to add those together and I get 2y is equal to, forgot my x, negative x plus 11. Alright, and they said let that be C1. So C1 is equal to 2y is equal to negative x plus 11. Then multiply A1 by 3 to create a new equation of C2. So it wants us to multiply A1 by 3. So we get 3y is equal to 3x plus 3. If you substitute, why is the solution to this system also 3, 4? Explain your reasoning. Well, if I substitute 3 and 4 in for x and y, I should see that both equations are true. Alright, so 3, 4 is a solution. When A1 was multiplied by 3, I did not create a new equation. All I did was just change it a little bit. Alright, both equations had 3, 4 as a solution. Therefore, when we add the equations, when we added these equations here, we still had the same solution because of our addition property. Alright, so why is the solution to the system also 3, 4? We did not create new equations. All we did was we changed them just a little bit. Alright? Alright, so what different approaches could we have used? Well, we could have guessed. We could have guessed and checked. We could have started with the 0.34 and realized that you could pick a slope that you want and then just move. Alright? You could have, when you multiplied one equation by a constant, did it actually create a different linear equation? So like for here, when we multiplied this by 3, did it create a different linear equation? Multiplying by a constant does not create a different linear equation. Alright? So when you added two equations together, did it create a different equation? It did not. Adding two equations does create a new equation. But okay, it does create a different equation because it gives us a different slope. Alright? But that's okay. Multiplying the equation by a constant did not give me a different slope. So that's why it's not a different equation. Alright, the following system of equations was obtained from the original system by adding a multiple of equation A2 to equation A1. So the new equation is D1 is y is equal to x plus 1. Equation D2 is 3y is equal to negative 3x plus 21. It wants to know what multiple of A2 was added to A1 to create D2. Alright, so what did we do to A1, or what did we do to A2 in order to get D2? Well, if you will look, A2 was multiplied by 2, and then they added A1. So A2 was multiplied by 2, and then added to A1. Alright? What is the solution to the system of two linear equations formed by D1 and D2? Well, we figured out that when we multiply and add these together, do we change our system solution? So we don't. So the solution is still three, 4. All right, and I can figure that out by making sure 4 is equal to 3 plus 1, and then substituting it in for that second one. Is D2 equivalent to the original A1 or A2? And explain your reasoning. All right, A1 and A2. Going back to A1, A2. A1 has a slope of 1. A2 has a slope of -2. Let's look at D2. D2 has a slope of -1. All right, so it is not equivalent to those two. So the slope of D2 is -1, and I figured that out by, remember, if I can get it into y is equal to mx plus b, so I'm going to divide by 3, and I get y is equal to -x plus 7. So my slope of this equation is -1, all right? And A1 and A2 do not have those slopes. Okay? Neither one of those have that slope. Start with equation A1. Multiply it by a number of your choice and add the result to equation A2. This creates a new equation for E2. Record E2 below to check if the solution is 3, 4. Alright, so let's just do this. Multiply it by a number. We're going to multiply it by 4. So it says multiply A1 by 4. So 4 times y is equal to x plus 1 would give me 4y is equal to 4x plus 1. Then it says add the results to the equation A2. Well, A2 was y is equal to -2x plus 10. So we're going to add those equations together. All right, so 4y plus y is 5y is equal to 4 plus a -2 is 2x plus 11. No, I forgot to multiply that by 4, so it should be 14. Sorry. All right, so I get 5y is equal to 2x plus 14. And it says, now check to see if the solution is still 3, 4. Well, 5 times 4 is equal to 2 times 3 plus 14. 5 times 4 is 20. 2 times 3 is 6 plus 14 is 20. And it is a solution. Therefore, 3, 4 is the solution of this new system. All right. Will this method of creating a new system work every time? Yes, it will always work because multiplying by a constant is a property of equality, and that keeps the point of intersection the same. All right? So it will work. All right. Why does the elimination method work? Solve this system of equations, of linear equations, algebraically. All right, so here's my original system. Now it says let's create a new system. All right, and then we're going to do or figure out our solution. All right, so here's what I want to do. I want to get rid of my y. So looking at my y, it's a -3 here and it's a 1 here. So the elimination method tells me what can I multiply this by to get rid of that y. Well, I'm going to multiply my first equation by 3. All right? So I'm going to multiply first equation by 3. When I do that, I get 6x plus 3y is equal to 18. All right? Now let's look at this. So then, here's my second equation. All right? Now, I'm going to add it to the second equation. All right, so I'm going to add it to the second equation, which means I get 7x. Those cancel out, and that is equal to negative 7. So then I'm going to solve it, and I get x is equal to negative 1. All right, so since I know that x is equal to negative 1, I can substitute it back in. All right, so the second step was add the new equations. All right, and I solved, and now I'm going to substitute. So I'm going to substitute negative 1 back in. It doesn't matter which one I do it to. So 2 times negative 1 plus y is equal to 6. So I get negative 2 plus y is equal to 6. I'm going to add 2. Y is equal to 8. And there you go. There is my there's my answer. I did something wrong. That should be positive. It didn't look right. That should be positive. So we're going to add a positive 1 in there. We'll try this again. So 2 plus y is equal to 6. Now I'm going to subtract 2, and y is equal to 4. And had I gone back and plugged those in, I would have figured out that it didn't work. Okay? So y is actually equal to 4. Sorry, guys. I knew I did something wrong. I just couldn't figure it out. Had to go back and look. Okay, so look at our exercises. Explain a way to create a new system of equations with the same solution as the original that eliminates variable y from one equation. All right, so let's look at this. I've got a 3y here, and I've got a negative 1y here. So I can multiply the second equation by 3. So then let's look at what our new system is going to look like. I'm going to have 2x plus 3y is equal to 7. I'm going to multiply this next one by 3. So I get 3x minus 3y is equal to 3. All right, then I add those two systems together, and I get 5x. Those cancel, is equal to 10. Divide by 5. X would be equal to 2. All right. Now I'm going to substitute x in. So I get, doesn't matter which one you plug it into. So 2 times 2 plus 3y is equal to 7. So 4 is equal to 4 plus 3y is equal to 7. Subtract your 4. 3y is equal to 3. Divide by 3. Y would be equal to 1. All right, so my solution, I would write it as 2, 1. I didn't rewrite this one up here, but it would be 1, 4. All right. All right, explain a way to create a new system with the same solution, eliminating the x variable from one equation. So I can eliminate the x instead of the y. Alright, so then let's look at this. I've got 2x here. I want to get rid of this x here. So in this case, because they're both positive, I need to multiply this by a negative. Because when I add them together, I want them to cancel out. So I'm going to multiply the second equation by negative 2. So my new system will be 2x plus 3y is equal to 7. Negative 2 times x is negative 2x. Negative 2 times negative y is positive 2y. And negative 2 times 1 is a negative 2. And then I'm going to add all of that together. 2 plus a negative 2 cancels out. 3 plus 2 would give me 5y. And 7 plus a negative 2 is 5. So I'm going to divide by 5, and y is equal to 1. Alright, so then plug back in. 2x plus 3 times 1 is equal to 7. So 2x is equal, or plus 3 is equal to 7. Subtract those 3, I get 2x is equal to 4. Divide by 2, x is equal to 2. So my solution would be 2, 1. Okay? Alright guys, if you have any questions, reach out and get a hold of me, and hopefully I'll be seeing you soon.